While we're waiting, I'd love to send a big hug to everyone out there who's likely running on low sleep, uh, high stress, and probably has been for the last 3, 4 days. So hang in there, everyone. I'm sure everyone's doing an amazing job. Hug ops indeed.
Thanks, Simon. Also, a little bit more housekeeping. We are recording this session, so I wanted to make everyone aware of that. I just saw hi from Germany. Hi, Germany. I miss you. I just came back from there for 3.5 years, so welcome from Germany. All over the world, I see now popping up. Very nice, very nice. Okay, the ticker has slowed down quite a bit, so I'm going to go ahead and start. I'll talk slowly at first. So hi, everyone, and welcome to the Log4Shell webinar brought to you by Snyk, where we're going to try to tell you today what you need to know. Now, this is a fluid situation, so tomorrow, what you need to know could be a little bit different. But for today, this is a point-in-time webinar. I'm Steve Kinman. I'm the field CISO at Snyk. As I mentioned, I just returned from Germany, where I was a CISO there, and this was, like every CISO's nightmare situation right before the holidays. With something like this comes out with tons of applications and teams and developers that you had to reactively support and try to get through these things. My helpers today are Simon Maple and Kirill Efimov from security, and I'll let them do quick introductions to themselves because they're the important folks on this call. Trust me.
Thanks, Steve. So, hi everyone. My name's Simon Maple. I am the field CTO at Snyk. I've been in engineering teams for the last 20 plus years and DevRel, community, etc. My background is very, very heavily Java. Been a Java developer for 20 years. Been a Java champion for 6, 7 years, I think. And presented at lots and lots of conferences, mostly Java user groups, those kind of things. I've been looking into Log4Shell and Log4j for the last few days quite deeply. So looking forward to sharing as much as we can to kind of help as best we can.
My name is Kirill. I'm security research team lead here at Snyk. I'm at Snyk for 3 years already. And yeah, last few days, Log4Shell was also in my view.
All right. So Simon, I think you're driving the slides. So go ahead and go to the next slide and we'll talk about a quick agenda. And so we're going to take you through what is Log4j, who uses it and why, and then what is Log4Shell and what is the actual vulnerability. We'll have a quick demo of the actual exploit. We'll go through some of the risk and impacts and how it's present in applications, how you remediate it, how you can use Snyk to find it and fix it, and then we'll have plenty of time left for Q&A. And I just saw a pop-up asking if this is being recorded. Just to reiterate again, it is being recorded. And so we'll try to get to as many questions as we can at the end. We do have in the find and fix section a kind of a cheat sheet on how to fix it that Simon and some of his folks came up with yesterday. And so we'll spend quite a bit of time there as well. So I think that is what we're going to try to accomplish today and take you on this journey. And so Simon, if you'd like to take it to slide 3 and take it away, and we'll get this rolling.
Absolutely. So obviously this is an hour-long webinar, and we hope you can stay through because there's a lot of detail that we want to be able to get through. But I would say if you can take just a few things away from this, these are the important TLDRs that are very, very important. So Log4j has a highly prevalent, or rather Log4j is a highly prevalent project. And as a result, there is a highly prevalent, critical, and very easily exploitable 0-day vulnerability that was disclosed on Friday in Log4j. And Log4j 2 specifically. It's called Log4Shell, which is the actual vulnerability name. Now, there's a couple of things that are really important here. First of all, being able to identify where you're using Log4j 2 in your dependency graphs and upgrading them to 2.16.0 minimum. The reason why we say 2.16.0 is because it also includes a lower serve denial of service vulnerability that we'll talk about in a bit as well. In some cases, you don't necessarily own the packages of things that are existing on your environments. So we'll talk about what other mitigations you can use where you can't do a straightforward upgrade. And there's a full remediation guide that me and Kirill wrote up yesterday. That's available here at that address. Feel free to grab a screenshot there or just Google Log4j or Log4Shell remediation cheat sheet, and you'll get there as well. Key important things to say is that this is very exploitable, that there is a huge number of attacks that are happening, and it's constantly moving. So the advice that we give today, as Steve mentioned, may well change day by day as more information from security researchers, as more information from how attacks are happening pass through. So we'll start off with what Log4j is. This is just to catch people up in case people are not familiar with this. So obviously with logging, it's a very, very important thing. Java applications log all the time about what is happening, who is doing what, particularly around exception paths and errors, so we can understand what is happening. Now, Log4j is a very popular logging framework that does just that. There are others, of course, as well, SLF4j, Logger, and other things that do this. But one of the things that this does is it logs, it uses the JNDI service which the JDK offers, which we'll talk about in just a sec. So what then is Log4Shell? Well, that is the name of the vulnerability that we just described a minute ago. It's a remote code execution vulnerability, which is a very dangerous vulnerability style. Originally, the advice was to move to 2.15.0, which will fix that vulnerability, but there are other issues that will be shown. It wasn't a complete fix, and we'll go into that in a little bit more depth. But ultimately, this is a critical CVSS score 10 issue. And actually, in some cases, it'll appear in Snyk as a Snyk priority score of 1,000, very much based on where it is in your application and other things like that. So for those of you who want to understand a little bit more under the covers about how the attack happens, very briefly, the JNDI or Java Naming Directory Service, a directory interface, is effectively a directory service, very similar to things like LDAP and stuff like that. It's a service that allows you with a unique string to be able to get some code or get the Java object back. Now in a JDK, it's very common for me in my application to make a request to the JNDI service and for that JNDI service to then return a data source, or in the good old days, an EJB interface, or something along those lines, right? Now, I can do that in a couple of ways. I can do that without providing a namespace, or I can provide a ton more information about where that JNDI service lives. Now, if I don't provide the full namespace, in this case, java:/comp/ et cetera, it'll assume the local namespace, the java:/comp. However, the attack vectors of what is happening here, and by the way, this is an attack vector which has existed for 5-6 years, actually disclosed at Black Hat. And the application here, when you provide a fully qualified URL here, so in this case, we're making an invocation to JNDI:/LDAP to my evil server with a port number /evil, in this case, trying to pull some evil request. I can send a request from this application to some remote LDAP server that I potentially stand up myself, which has this evil object, which can then be sent back and can execute code in my application. Now, this is still okay somewhat because, well, I say okay somewhat, there's an evil JNDI directory here. It's okay somewhat because this is actually coming from my application. Okay, now the reason why this is such a dangerous exploit is because the Log4j service uses JNDI, and it uses JNDI because when it logs, one of the things that is a nice benefit to it is to be able to go using the JNDI, grab variables, grab information from the JNDI that it can use to enrich its logs, to enrich its state. So knowing that that Log4j can use JNDI lookups to gather information and use that for its logging, the attackers use that previous exploit that I mentioned there to say, well, if I log a dangerous string Log4j will take that dangerous string, try to log it, notice there is a string in there, such as this one in the second line, the dollar curly brace followed by that evil URL. And what it will do is it will try and resolve that. And it will then go to my evil JNDI or my LDAP instance, pull back an evil object and start potentially running things in that remote instance. So, for example, the bottom example here is a snippet from my evil object, whereby what I'm doing is I'm grabbing the runtime, I'm doing exec, and I'm curling the etc password out to some evil place. So I'm, in this case, grabbing data from an evil place. So this is something that is again, out the box, easy to exploit. Log4j is used everywhere. It logs all the time in Java applications. Very, very common thing to do. And it can very easily be passed a string that evaluated will send it back out to potentially an evil JNDI, JNDI location. Now, in terms of how we get an application to log, that's fairly easy sometimes, particularly if we try and push it down routes that we know applications are going to log, maybe an error route or an exception route or something like that. Yeah, this is the best way of trying to find a log location. But we're seeing a lot of attacks happening here with these random strings being passed. So let's see this in real life. I'm going to hand over to Kirill, who's going to share his screen, and we're going to see an example demo of this. And we're not frightened of sharing this because obviously there's so much information and data about how to exploit. We just wanted to show you this in real life.
Yeah. Okay. Basically, what I'm going to show today is the simplest possible, maybe one of the simplest possible Java HTTP servers, which is vulnerable to this vulnerability because of using a vulnerable version of Log4j. First of all, let's have a look at, and like I'll try to show as less code as possible to make it quick. But if you have any questions, go ahead and ask, and I'll share a link to the vulnerable application after the demo. Basically, like we have Gradle project, and you may see two dependencies, which is Log4j core and Log4j API, both vulnerable version 2.14.1. And the server itself is basically 40 lines of code. It's all implemented in one main function. Like if you're Java developer, you will quickly recognize what's going on here. We just listening on port 8000, and we handle all requests to /endpoint and just serve index HTML file. And the index, like, literally just serve it to customers. And the index HTML file is like one H1 tag, almost empty, right? So the vulnerable part here is basically logger.debug. Like you can see that what we try as a developer, what we try to do here is log user agent of the browser which opened the page. Let's see how it works. I'm going to run it in Docker, and we will have all logs going here. So now it's running, and we can go to the browser, refresh page, and see nice empty page. And in logs, immediately we can see user agent, right? We can do the same via CURL and just request this page via the CURL. And what we're gonna see in logs is basically user agent is CURL 7 something, right? But if we specify user agent, we actually can trigger feature of Log4j. And the feature is basically it's called lookups. And whenever you have the templates, the template science here, and you can execute different lookups in the log. And like whenever you execute this, everything is the same, right? Response is the same. But if you look at the server side, at the server logs, you will see that instead of our string provided in user agent, we actually can see like runtime version in this case. And like this is not a vulnerability itself, but you see that user input got interpolated to some stuff behind, like on a backend. So let me show you the second part of the demo is basically evil class. I'm not going to show full server which like implements LDAP protocol and do behind the scenes like serving the evil class, but the only evil class itself. Basically, this is code you can run as a hacker, right? Like you can put here whatever you want, but my goal here is to replace index.html inside Docker container with something which like hacker wants to do. So I'm going to run this server, the LDAP server on my localhost, and you can see I have LDAP server listening on port 9999, and I'm going to execute this CURL request, and user agent is going to be linked to this malicious LDAP server. Basically, it's because I'm running inside the Docker, it will be the host Docker internal and the port, as I mentioned, 999. Let's run it, and you immediately can see the output, which is what hacker is intended to do. And like if now you will update it in the browser, it will be this way for everyone. So we were able to poison, to exploit server and put our own index page instead of what was intended by developer. Basically, that's it. I'm going to share links in the chat now. Back to you.
Thank you very much. Let me reshare my screen. And Steve, over to you in terms of what the risks are of this kind of attack.
You always have to start at the top, right? So the biggest risk is your supervisory board or your CEO coming in and saying, "Are we affected?" And if you don't have a great answer, that's a risk, right? And a lot of security teams in the world, when things like this happen, don't have a good answer. But you start thinking about those risks of remote code execution. And if you're a regulated business, you know, the regulatory compliance, it's huge. And so your next audit, your auditors are going to ask that question, like, how did you do with Log4Shell? And it can go all the way into your cloud stack with infrastructure as code and containers and all of those things. Like your control failures there could be rampant. And then you have to, so you also have to think about your third-party SaaS. Like, what am I using that is affected? Is my SIM affected? Is it, lots of things. As Simon said, everything needs logging, and as security teams, we really want logging. So this caused part of the problem was our great security mindset of let's get logging in place. The risk, pretty straightforward. Remote code execution is bad. Remote server control is bad. Increased insider threat. That's one a lot of people overlook. It's like, if you have, everybody wants to believe they have great, good employees, but there's always that one that if they find a way and you make it easy, they're going to try to see what they can get to. And so insider threats really increase here. Simon, if you'll go to the next slide, please.
Sure.
And, with remote code execution, you can deploy malware, you can deploy ransomware, which then you have an exponential problem starting to form. Like, where is it gone? It's no longer this vulnerability, it's some other thing. And with complete server and application takeover, it's the same. You can get all the data you need. Folks can change the data. They can take your data down. And you know, when you think about security, that's really what you're trying to do is protect data. And so that all of those options of things to accomplish with this remote code execution are a little bit terrifying. And then one that most people forget about is like, can they disable other security services? And then how long would it take a security team to find where they've done that? So this is the tip of the iceberg when you think about it. If they get in using this method, where do they go? That lateral movement. So I think you know, that's really some of the risk and examples of the impact. And Simon, if you go to the next slide, one of the things that makes it even more terrifying for a security team is, do you even know you have it in use? So we did a quick survey and 35% of Snyk customers are using Log4j, but only 39.2 of that number is direct. 60.8% of it is indirect. And by that we mean libraries with transitive code. And so if you don't do good asset management, or you don't have SBOMs, or you don't know what your software is actually built using, then you really may not know if you're affected. And you know, developers are doing their job. They're trying to deliver cool things, where security teams are trying to deliver security. And if they don't know where this lives, then, you know, I've talked to a few of my colleagues over the last couple of days, and it's chaos in a lot of these areas where they're trying to just figure out if they're affected. So they can't answer those questions to the supervisory board, to the C-levels and things like that. And to describe better what I mean by transitive dependency, I'm going to kick it back to Simon for the next slide, and he can explain this much better.
Sure. Yeah. So typically, and there's a little bit of chat there's a few comments in the chat about the SBOM, which may not be too familiar with people, but this is the software bill of materials. Your bill of materials is effectively the list of components that you're using in your third-party library. So your application, which we would see at the top here, this application will be pulling in a number of direct dependencies. So you can see these first level dependencies are direct dependencies. So these two at the top, and then these three at the bottom. Now, this second one here, this struts bootstrap plugin, this is going to pull in its own dependencies. So that has two transitive dependencies, this struts core and velocity tools. Struts core then pulls in a further 3 transitive dependencies, et cetera, et cetera. And this is how we create our dependency graph. Now, Log4j is an interesting package to have such a severe vulnerability in, because Log4j could be used directly by your application. Maybe you're using it for your own logging. It could be used by your dependencies themselves as their logging framework. It could be being used by your application server as its logging framework, or your web frameworks, et cetera, et cetera. So one of the tricky things about this is this will be found all over, potentially all over the dependency graph. Quick question in here about the Log4j core. Log4j core is the package that, or the dependency that has the vulnerability. What you will likely need to do is make sure that the API version is likely in sync, just to make sure there's no mismatches in capability. So Log4j core is the affected library from the security point of view. In terms of fixing, well, if it's a direct dependency, it's a much easier fix, because we're looking at upgrading our direct dependency in our POM XML or a gradle build file to the necessary version, which in this case is what we're suggesting is 2.16.0, and this is what Apache is suggesting as well. And if it's a transitive dependency, then of course you need to wait until one of your direct dependencies pulls in that fixed version. Now in Java, of course, the way what we usually call jar hell or dependency hell is where you can only have one version of a package typically being loaded by a class loader. That works in our benefit here, because if we can make sure that the one file, the one class that is being loaded here is the version 2.16.0, all our transitives as well will be loaded in that same one. So it's a little bit nicer there as well. a couple of questions here that I can just answer while we have this screen open. Is this screen based on the binary scan of the POM file? This one's actually based on, I believe, the POM XML, but you can use Snyk in a number of different ways with other tools and vendors. So, for example, you can use Snyk in AWS Inspector, for example, and that will provide you that will do some fingerprinting on which jars you're using and use Snyk data provided with that. Also, similarly with other things like Dynatrace and Datadog and stuff like that as well. A couple of other questions. Yeah, Snyk is the static code tool which is helping, and we can show you a demo of that in a bit. And yeah, importing every repository into Snyk is very, very important to actually be able to get that breadth of your packages in. There's some questions about benefits, latest JDK versions and things like that. We'll jump onto the remediation in a bit. In short, there is a very, very limited benefit. It's not actually as big as was originally thought. It's always good to stay on the latest, on the closer versions, but in this case, there's not actually as great a benefit as originally thought. With that, I'll pass back over to Steve.
So yeah, real quick, just to wrap up this section, why are we all here? So Log4j is very popular. As I mentioned, security teams are begging, application writers to log their applications. So it's very popular. It's widely used. Security teams also need to know what and who is using it, and that's hard to do with this because of the transitive ways of use. So you may not even know you're using it. And this, I read an article yesterday that said this will be around for years, and it'll keep rearing its ugly head because people will put it back into play, or it's in a dependency you don't know about. It's very accessible and very exploitable, and it's remote code execution, as we put here, is the holy grail. It's what every attacker wants to get, because then they can laterally move wherever they need to go. And the fact that it was 0 day and it's been exploited for a bit of time before we had our run at it as a industry, as a security industry, as developers. It's really very concerning. So, and you can tell by the amount of folks on the call and the amount of interest in this across all of the social media platforms and the news, and my wife and everyone else who asked me, hey, are we affected by this? It's big. So that's why we're all here. And I think the next slide where Simon and Kirill go through a few ways to fix it is what we all want to see in here. So take it away, Simon.
Cool. So this is a cheat sheet that we wrote yesterday based on advice from a number of different sources, but staying very, very close to the Apache advice. And these are, you don't necessarily only want to do one necessarily. You might want it, largely depending on which of these you are able to do, you might want to do more than one in this case. So let's start with number one, which is about gaining visibility. And this is really, really important because you need to understand all the paths of where Log4j is coming in. And one of the best ways that you can do that is really just to try and import as much as you can. If you've wanted to use Snyk, more than welcome to use Snyk. Snyk has a free plan. So if you're not a Snyk user today, you can go up and do a self-serve account creation and just start scanning your projects for free. And you can do that on the command line. You can do that in a Git repo. You can do that in CI, however you wish to implement it. It'll identify the dependency graphs and identify where Log4j is being pulled in, whether it's direct or transitive. And that's a core thing. Other things that you can use, there are some other tools as well. Maven is a very, very popular build tool, of course. So here is Maven dependency tree. For piping that with grepping for Log4j is another way that you can be able to look at that for identifying where you're pulling in Log4j into your dependency graph. Anything to add on that, Kirill, about how to identify paths in dependency graphs?
Yeah, like the first one is pretty obvious. Basically, just scan your application for dependency directly or transitively. That's it.
Cool. The second one, a little bit more interesting now. Actually, once you've found all those, of course, what you actually want to do is start mitigating those. So this is the first real mitigation one, but the first step is there because it's so important to actually be able to identify. This one is now upgrading your Log4j versions up to the in this case, the latest version, but this is the minimum jump that eliminates both of the new known vulnerabilities. So Log4j, the main Log4j remote code execution seems fixed in 2.15.0, but there is a further vulnerability, a much lower severity vulnerability, which creates a DOS, a denial of service attack possible. That is in 2.16.0. 2.16.0 is also a much more fuller, complete fix for this remote code vulnerability because it entirely disables JNDI by default. So once you do that, you know there's no way that can work in a similar way. You can do this in a number of ways. The Snyk automatic fix we'll show you in just a second, but this is effectively connecting to your SCMs, your Git repos, and pushing a pull request across to fix that issue. You can also do it manually. So if Log4j is a direct dependency, you need to go and try and find where that's being pulled into your POM XML and identify where that is. If you're using it as a transitive dependency, you need to try and identify a version of your direct dependency which pulls that in, or like I said before, because class loaders can typically pull in one version only, you need to make sure that is the version that is being pulled in. Question come in about Snyk versus GitHub Dependabot. There is actually a big difference here because Dependabot, only from what we've seen and from a lot of noise that has been going on Twitter particularly, GitHub Dependabot looks like it isn't able to find transitive isn't able to find Log4j as a transitive dependency if you are not using a lock file, and that's a very significant limitation in this case, just because Log4j 2/3 of the time is going to appear as a transitive dependency. So it's a pretty dangerous way of doing that. There is a good suggestion here about auto PR. If you're able to stay on the latest version and that is your approach, then auto PR is a way of actually being able to do that. Snyk can do the auto PR to make sure you're on the latest version, or auto PR if you based on your security records as well. Anything you wanted to add on that one, Kirill?
Yeah, maybe I would say that there is two versions where, like, the first version where fix was introduced is 2.15.0, but we still recommend to update to the latest one, to the 2.16.0. And yeah, 2.15, like, it's a little bit confusing. We will talk about it in the next slides. It also has a vulnerability, but probably not that severe.
Yeah. One thing just to mention here on the Spring side. So Spring uses SLF4j today by default, which isn't, it doesn't appear vulnerable. SLF4j, you can set it up so that there's a bridge where that uses Log4j, in which case if you're using the Log4j, I believe that is a vulnerable space, but you would need to make changes to your configuration there for it to use that. But this is just to mention that make sure you're looking at your core vendor website. So if you're using Spring, take a look at the Spring advice. If you're using other vendors, take a look at that as well, because it's really important that you listen to those people are absolutely going to look at this in depth. So that's an important thing to mention as well. Okay, number 3. So let's say you can't perform an upgrade. What's the next best thing? Well, strong advice here is to remove the JNDI lookup class. So you can do this through identifying, doing searches to identify, where your Log4j jars are, for example, and then removing that using a command like this, the zip command, which removes that JNDI lookup class. Now, a big caveat on this one, of course, you can't, if you just remove classes from runtime, you can potentially expect a little bit different behavior. Now, I think if you're not doing JNDI lookups typically in your logging, then this likely isn't going to be a problem at all, but you might experience slightly subtly different behavior in your runtime, this being the case. There are also some other classes which could be important to remove. JMS appender, I think, is a very important one there. JNDI manager and SMTP appender equally, there is advice on the web to say these are classes that you should remove as well. Anything to add on that one, Kirill?
Yeah, this one is interesting actually, because this has a good use case. I mean, imagine you have like GitHub Enterprise Server or something similar, which you're not able to control at all. I mean, you don't have the home file, you don't have a manifest, you can't change version of the dependency in there. And like we faced this problem internally, and I really recommend this item for remediation whenever you have Java application which is not under your control, direct control. So you can still go to the Docker container or the way how you deploy it and just modify the jar file of the Log4j core and just delete this JNDI lookup. And you also mentioned the GMS appender class, which is relevant for the first version of Log4j, and I guess like let's talk about it a bit later because we have dedicated slide for the first version.
Sorry, just answering some questions at the same time. Sorry about this. Okay, so next up is disabling lookups via properties. Now, this one, there are more caveats, I think, on whether this this will work with depending on versions. First of all, you need to make sure that you're on version 2.1.0 or greater. So 2.10 as a minimum to add that. That does look like something that that does protect. However, with the second vulnerability that was added, this doesn't look like it's something that that can protect you against that. There's a couple of ways of doing that. One is as an environment variable, which is that first log4j format message, no lookups, setting that to true. Another one is an environment variable. Oh, sorry, another one is a JDK environment variable, which you can add when starting the JDK. Anything to add there, Kirill, on properties?
Yeah, maybe worth saying that in some, like as you mentioned, for another vulnerability, in some cases, if your configuration is like crafted at the specific way, you still will be vulnerable for another vulnerability, like which is 2.15.0. So maybe I would recommend, like whenever it's possible, to still stick to the second or third remediation.
Yep. Yep, sounds good. Now, this number 5 is an interesting one because originally there was data or people stating that upgrading your JDK to certain versions, certain updates on your different major versions could protect you against this issue. It turns out that there are other ways, and actually quite easy ways, to still attack Log4j on any JDK version. So it's really important, and I'll say this again, upgrading your JDK will not protect you from the Log4Shell. Really important thing to mention. Doesn't matter whether you update the trust URL code base to false or not, there are still plenty of ways in which you can be attacked using Log4Shell. Kirill, anything on that?
Yeah, maybe say like why you not protected, like still, because there is a possibility to you have a gadget which will allow remote code execution in your class path, and like even without making remote request to remote server, you still can be vulnerable to RC in some cases.
Absolutely. Okay, 6 and maybe we'll do 6 and 8 together, because I think these are ways in which you can't rely on necessarily, but it's a nice bit of a safety net. So the previous examples that we talked to you about, upgrades, removing support, removing classes, they're the ways to really make sure that an attack can't happen. There are other ways, like safety nets, in which you can say you can use a WAF or you can use egress to make sure that requests that are coming in, so these are your malicious requests, there could be rules that can identify malicious formats or malicious payloads that look like a Log4Shell attack, and those can be blocked, those can be denied. Equally, from an egress point of view, you can start denying and blocking requests coming out from your environment to places that look like it's going to be, you know, some dangerous place from your loggers. Now, I mentioned that these are I think the WAF one is probably a little bit more dangerous because WAF rules get circumvented all the time. And just because you have a WAF rule that works this minute, as soon as a WAF rule comes out, an attacker will find a new way of circumventing that WAF rule. And we saw it time and time and time again over the last few days that everyone thinks they're safe with a WAF rule, but then a way to circumvent that happens instantly, and then all of a sudden everyone uses that new rule. So they're not by any means. Oh, sorry, WAF is a web application firewall, similar to a firewall, but typically used in cloud environments and things like that. It's a web application firewall. Yeah. So it's a nice safety net, right? It's not going to hurt you by having these kind of things in there, but don't rely on them. The previous ones that we mentioned are much more reliable and safer to use. Any comments on the WAF or egress? Kirill?
Maybe I would say something about WAF because this, like, you can already find some ways to automatically generate WAF bypass payloads for this vulnerability. So it's really flaky. I wouldn't recommend, like, maybe it would protect you from automatic scan, like whenever, you know, like people scan all the websites or IP address ranges for this vulnerability. But if you will be directly targeted, probably this is not the best protection.
Mm-hmm. And then finally, number 7 here. I always think this is an important one. Whenever this is about monitoring projects, and this is actually quite specific to Snyk. One of the things when you do an import of a project with Snyk, what it will do is it will continually monitor and test daily to make sure that as and when new vulnerabilities occur, you will be protected by that. You'll get a pull request sent to you automatically, for example, to say this is the new version you should be on. Now, the reason why this is very, very important on these kind of vulnerabilities is because the whole world right now is looking down at attacking, at mitigating, et cetera, et cetera. This is a place where there's so many security researchers, so many attackers trying to find issues in these areas. We saw 15 come out, we saw 16 come out. For all we know, there's going to be a 17 in a couple of days. We don't know. So the idea of making sure that you're not just safe now, but you monitor the situation, certainly over the next days, weeks, and months, is very, very important. So I think monitoring is extremely useful as well. Before we go on to, I think actually there's a lot of people talking a little bit about how to find. Any additional before we jump into the finding of these issues, Kirill?
No, I think all good.
Cool. One of the other things there just mentioned is about sometimes Snyk Portal imported a project from Bitbucket, also used Snyk ID, and there's maybe a mismatch there. One of the reasons why this could be is because depending on different environments, the Snyk UI, for example, looks at just your POM XML and it will create a dependency graph based on that. Doing the same at CLI in your CI environment, for example, will actually look at the actual environment which is built up using things like the Maven dependency graphs, etc. So if there are environmental changes or slight differences in the way your applications are being built, we can only do what we can with the information provided. So look at the Snyk testing in your closest as you can, I would say, into your production environment, because that will provide you with the most accurate results. But yeah, absolutely look at why the difference could be happening there in your environments rather than anything else. And actually, Nima, thank you very much for that precise command. I saw that also as well, and I will get this updated. And I also saw the Gradle one, which I'll make sure I add to this as well. Okay, so this is one of the reasons about using Snyk is to get great security intelligence about these issues. Kirill, why don't you take us through the Snyk vulnerability database here with this disclosure of this issue?
Yeah. This is the screenshot of the vulnerability page, and you can see that it has like 10.0, the most critical severity from Snyk, and it's not only because of CVSS vector, which shows that the vulnerability is critical, but also because it's trending on Twitter, it's trending everywhere, and you have the exploit, which is like basically everyone have an access to exploit, and a lot of scans going on at the internet, as was mentioned already. And on this page, you also can find some useful remediation advices. And we mentioned here as well that if in cases that you cannot upgrade the vulnerability, you can delete JNDI lookup class from your jars. So basically, you will see this page if you scan your project and the vulnerability appears in your project. And like if you see this page, you should take action as soon as possible. I guess we can go to the next slide and actually discuss the second vulnerability, like denial of service, which we have in another version of.
Yeah, just a couple of things before we move on. Actually, there's a really good comment here that says in this image, and it says Java 8 update 121 protects against remote code execution. This was actually an older screenshot, which I will get updated. So thank you for that. As I mentioned, this is a moving target, and with advice that is given from Apache and others, changes. And we keep this updated. So I believe the latest version does not have that. But yeah, I'll double check on that one. Just to clarify, the JDK version does not have sufficient impact to be used as a complete mitigation. One other question that I want to handle is here. This says version 2.15.0, but we are in the presentation talking about 2.16.0. So just to clarify, and this will actually lead us on to the next slide as well, the remote code execution here was fixed in 2.15.0. However, it was only partially fixed. A new vulnerability, which Kirill will talk about on the next slide, did come about, which is fixed in 2.16.0. So our recommendation to fix both would be go to 2.16.0. Although if you did move up to 2.15.0, you would, by the looks of it, actually fix the remote code execution, which was the higher SEV vulnerability. But if you have the choice, 2.16.0 is your target that you should be jumping to. Yeah. And here's the second. Please add anything that I missed there, Kirill. But this is the second vulnerability.
Yes, this is the second one, and this is about 2.15.0. Basically, this vulnerability is relevant only for 2.15.0, which was published as a first remediation fix by Apache team, and basically, like, what's the difference between 2.15 and 2.16.0? The main difference is that, like, basically here it is possible if you have some really specific configuration in your files, it is possible to perform denial of service attack to your application. And I guess this vulnerability will be changed in the future, because it's still a lot of investigation going on about it. It's not certain if it indeed, like, if 2.15.0 indeed protects you from RCE, although we don't, like, internally, we don't believe that 2.15.0 has RCE vulnerability. We believe, like, it only has the denial of service vulnerability, but it's still investigation going on. So it's why we recommend you to update to 2.16 like as soon as possible. And like, we decided to publish it as two independent vulnerabilities, not kind of change range for the previous one, not say like the RCE vulnerability should be is introduced in 2.15.0, but instead create a new one which dedicated for 2.15.0, because we are almost certain that this is much less severe vulnerability than the previous one. And yeah, and we have another slide which is talking about first version of Log4j, and a lot of people actually in the chat asked about if Log4j 1.x is affected as well. So this is a vulnerability about 1.x. And I would personally say it is really, really controversial. It's not, first of all, if you have this vulnerability, you most certainly not affected. I mean, like, there is still a chance where you have, if you expose your configuration, if your configuration is editable by, let's say, website admin or another person, basically, it's still possible to execute code. It's still possible to have remote code execution on your server, but it's very, very rare case where you have editable configuration. So we have like big disclaimer here on top, and basically version 1.x is much, much more safe than to like versions before 2.16. So this vulnerability is more like info for you. Like, it's better to fix, definitely. It's better to close this one and like keep yourself updated. And it's definitely better to delete JMS appender class from the jar if you have it. But like, you shouldn't be worried as much as about the first vulnerability.
Awesome. So I'll jump actually to how we can fix, and then we'll do a quick demo of a test and a fix using Snyk. So in terms of how you can fix, well, with Snyk, you can do things at the command line. You can do things at your IDE. So you can test with Snyk to identify whether that's happening in your local development environment. Also, you can import and test via the SCM. So you can import Git projects in, and you can also pull reports upon them as well, which we'll cover in just a sec as well. You can very easily remediate with either automatic pull requests or manual pull requests. The automatic pull request is what I mentioned with Snyk, testing your projects daily with that monitor. The manual pull request is simply you clicking a button, which I'll show you in just a sec. And this is the SBOM, the software bill of materials, which Steve mentioned, showing the list of dependencies that exist across all your projects. So what you can do is, as being shown here, you can identify look at a single dependency at a specific version, in this case, Log4j core at version 2.3, and we can determine which projects are using that package. So you can identify where in your entire organization, after importing all these projects, where you are most affected, in which projects and how they're affected as well. Of course, there are APIs which will make a lot of this a lot easier as well. So let me jump across to a demo. So I'm going to go to a Snyk website, snyk.io. I go to login on that Snyk website, and I'm going to quickly go to my projects page. So again, everything I show you is entirely free, entirely self-serve, so you can do this alongside me if you want. Now, this is my dashboard where I have all my projects. What I'm going to do is simply click on Add Project, and I'm going to import a sample project, which I know in this case is vulnerable, but I perhaps don't know this across my entire organization. So I might want to import a good number of projects here. I'm going to import it from GitHub. So I click on my GitHub user, and I'm going to grab, let's see, where is it? I think it's Log4j Shell POC. If only all vulnerable projects were quite so obvious. There we go. So this is importing now. What this is doing is it's trying to identify files which it recognizes that it can scan for either Snyk code, Snyk open source, Snyk container, or Snyk infrastructure as code. And when it finds one of those, it will perform a specific scan type on it to identify vulnerabilities. If I click the log file, you'll notice it's found 2 files. it can find a POM XML, and it can also find a code, Java code, that it can run static analysis on. So I'm going to click on this POM XML. If I click on View Projects, what you'll notice is, first of all, let's go on to dependencies. And this shows you the dependency graphs which are being created. Now you can see the Log4j API is there, but not affected. However, in this case, the Log4j core is at version 2.14.1. This is a vulnerable version, and as a result, you can see my critical and also a low SEV vulnerability. If I click on issues, you will see that this is the Log4Shell vulnerability. It's telling me a ton of information there. It's telling me I need to upgrade to version 2.15.0. This is the version that has the remote code execution fix. I also have this denial of service vulnerability, which Kirill mentioned. This has a fix in 2.16.0. Now I can either do ignores, create issues, or of course, this is a very severe vulnerability. I need to fix this. I can fix vulnerabilities individually, or if I go to my fixes tab, you'll notice I can batch these fixes across one change. So if I upgrade directly to 2.16.0, I fix both of these. And in that case, I'm going to click on the Open a Fix Pull Request button, and it's going to do that for me. You'll see both are selected, and I go ahead and open a fix pull request against my Git repository. You'll see a number of things here. You'll see the fact that actually what I'm actually fixing. You'll see that there's a mature exploit on this one. There's no breaking change, but you'll see what I'm upgrading. If I go ahead and click on my files changed, you'll see the exact change I'm making, which in this case is a version bump from 2.14.1 up to 2.16.0. And if I click on conversation, one of the other important things that I think Bridget asked is testing on pull requests. So what this is doing is this is testing the delta change that I'm making, which is in this case, just that bump. It's not testing anything else other than the changes I'm making in the pull request. And it's identifying if there are license additions that are against policy, against my policy, or if there are security violations, security issues that are being introduced because of this pull request. Of course, what I want to do is I merge this, restart my environments, and use the valid code. Snyk can indeed be used in enterprise GitHub as well, which also enterprise GitHub does suffer from this vulnerability as well. So do make sure you're looking at your enterprise GitHubs as well. We're pretty much at time. I think we've done a lot of questions. We've done a lot of questions all the way through. If you do have any other questions, feel free to reach out afterwards. We'll see actually if there's a couple of versions. Is this a paid-only version of Snyk to do this? No, Snyk is self-serve. There is a freemium layer, and everything that I've showed today is perfectly possible on the free layer. So if you go to snyk.io, you can just log in using your GitHub account or something like that, import your projects, run your tests. There is a limit on the number of tests, but it's like 200 tests per month. So you can do that. There is in terms of tiers, there are a number of tiers. There is a team tier, which is for small development teams, and then it goes up in other paid tiers as well. So there is a freemium for individuals and a paid tiers as well. Okay, so we'll go through the chat as well and try and go through a ton of the other questions. Anything else you wanted to add, Kirill or Steve? We're pretty much at time, but anything you wanted to close with?
Yeah, maybe.
Sorry, Kirill, go ahead.
Yeah, maybe I would answer one question which personally bothers me. Like if you're a Java 7 user, you basically can use only 2.12 branch of Log4j, so please update to 2.12.2 version.
And I believe that disables the JNDI as well. Is that correct, Kirill?
Yes, yes.
Yeah. Anything you want to add, Steve?
Simon, there was one question that was early on that I wanted to see if you could touch on real quick. It's in the Q&A. It's also in your Slack.
Which
I'm going to put it back in chat here, just so we can. know we're out of time, but to me it looked important, so I just thought I would.
Oh yes, no, that one I covered. This is about potential different. Yeah, this was the one about in case you get differences between using Snyk in the UI versus using Snyk at the CLI or in an IDE. It's typically because the place that you are running in Git. In a Git repo, for example, is going to have very limited information. It's going to see the POM XML, but it doesn't necessarily know its runtime. It doesn't necessarily know other things about the environment. When you run things in CI or in your Git repo, you're looking at applications that are being built, applications that have an existing Maven installation there that we query as well. So it uses additional data and can very often get more accurate results. Typically, they're actually very, very similar. So they're very trustworthy, but you do get you do sometimes get subtle differences.
Thank you.
No worries.
Okay, I think we're out of time. I appreciate everybody's interest in this, and Simon and Kirill, thank you so much for the deep dive on this. And I'm sure there will be, like I say, it's a fluid situation. And I'm sure there will be more of these coming soon, and we can take some notes away and try to target some of these other questions we see.
Yeah, and I'll say going forward, just to finish going forward, keep an eye on the Snyk blog. We'll be updating information there. Keep an eye on the Snyk advisories, and the Apache site as well is a great place to get more information direct from the folks there.
Very good.
Thanks very much, everyone.